Hello, sixth grade. We're doing Investigation 1.2 Summary for Variables and Patterns. So our first thing here is the definition of a variable. It's a quantity that can change. It's usually represented by a letter in rules or equations. You can use any letter of the alphabet to represent an unknown number, and that's called a variable. Now, in today's lesson, we looked at different time distance graphs. And we're going to look at what they mean, what the shape means. So there's what we call different types of motion. So here, if I follow this straight line, okay, it's a steep straight line. So first of all, a straight line means that we have a steady speed. Okay, the steeper the line, the faster it is going. So if I compare this straight line to this piece of this straight line, this one is going faster. It is steeper. Okay, it's not about the length. Okay, it's about the steepness. So if I have a steep line, that means I'm going at a steady pace. If I follow this line, this curve, this means that you're getting faster because it's curving and it's becoming more steep. So it's not going at a consistent rate. Okay, this is the same rate. This is starting off slower and it's going faster, 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 faster because it's curving to be more steep. Okay, so now again, as my time continues, we're talking about distance. So here I'm going at a steady speed. Okay, as soon as I plateau here or I go flat, okay, if you notice my distance isn't changing, but time keeps on going. So therefore that means I'm stationary. I've stopped. Okay. In this case, I am now returning to where I started at a steady pace. So as I go down, okay, I'm not going like down a hill, I'm going back. My distance is decreasing, so I'm going back to where I started. So we use these to help us interpret, or we could tell a story. So first we have to look at, if we were to be told, describe a story, we first have to analyze. Here I have minutes. Okay, so that's important. At the bottom I have time. So it's a time distance graph. And my distance is in meters. So that kind of helps with my story. I'm not driving miles away. Okay, I'm just going a distance in meters. So from this section here, okay, my distance is increasing and it's increasing at a steady pace. Okay, so in the first 6 minutes, I've gone 10 meters. So maybe my story might be that I'm going to the park. So my first part would be that I walk to the park at a constant pace for 6 minutes. Then this section, I'm not moving. So maybe I sat on the bench. I'm at the park, okay, and I sat on the bench for 1, 2, 3, 4, 5 minutes. So then I sat on the bench for 5 minutes. And then here I'm going back, so I'm returning home because my distance from where I started, okay, is getting smaller. So I'm returning home, but I'm not going at a constant pace. Going fast, a little bit slower, and then fast again. So then I return home, okay, at a changing rate. So now again, our story could change. It doesn't really matter. We kind of went with somewhere I went consistently a distance. I stopped. And then when I went back at a different rate, at a changing rate. So now on the backside, we're still looking at, we went in investigation 1 from a table to a graph. Now we're going to collect data from our graph and put it within our table. So I'm going to look here. We're going about time in seconds, and we're going to have to add. I know I don't have enough, so let's just go up by 10 seconds. And again, let's put SEC up here for seconds. So 0, 10, 20. I'm just going up by tens because that's what my scale is. And then because I'm going to need to add 110 and 120 here. Okay, so So now I'm just at 10, I went up to 20. My distance is 20. Oopsie, sorry. I should say at point 0, we're starting off at a distance of 0. At 10, we're going a distance of 20. Now at time 20, I'm up to 40. At 30, I'm up to 60. At 40, I'm up to 80. Obviously, we're going, so you can see how that's consistent, 20, 40, 60, 80, and my line is going consistent. And then at 50, I am at 100. Okay, now at 60, I've gone down. I'm here. So at 60, I would say I'm somewhere between, I would say halfway between 60 and 80. So let's say we're at 70 meters. And then at 70, we are at 40. Okay, because I went down by 30. And again, it's a straight line. So I went down by another 30. Now at 80, I'm going back up again. And I'm at 80. At 90, I'm at 120. So again, now I'm going up by 40s. And at 100, I am at 160. And then now I don't move. Okay, so the rest I'm at 160 and I'm at 160. So now the question is, as we're analyzing, during what time interval did the distance change the most? How can you determine that from the graph? And how can you determine it from the table? Well, between 70 and 80, okay, I started going up by 40. And then I continued that with 40. Where here, I was going up by 20s. Okay, and here, I was going down by 30. So between 70 seconds, 70 to 80 seconds. And you could say the same, that it was between 80 and 90, 90 and 100. Okay, it increased by 40. Okay, increased by 40 meters. Now, how can we tell this from the graph? Well, look at my incline. I have a steeper incline here, okay, than I do from here. So from the graph, I have a steep incline. Okay, from the table, okay, the difference between the distance, difference in distance. Greater. So our graph is a steep incline. My table, a greater difference in the distance. Again, we were going up by 20s over here. We were changing by 30s here. And we were changing it by 40s here. And that's how you could tell from the table. Then it asks us, what are the advantages or disadvantages of tables and graphs to represent the pattern? Well, a graph is more visual, and you could see changes easily. Okay, more visual, and you could see changes or trends. Okay, a table is you can get the exact amount. You're not guessing. Okay, so for here, in this investigation, we looked about how the lines tell a story, and then we went from graph to table in this case.